interpretive naturalist with the Elkhart County Parks. We're going to talk about wetlands today. And most importantly, we're going to talk about the biological factors that can help us determine if the water quality is good or great. And we're hoping for great. So let's talk about it from the beginning. What makes a wetland? It has to have three components to be a wetland officially. Number one is water. It has to have water for at least part of the time. It can be a temporary wetland. It can be a permanent wetland like a lake or a big pond. Those are all different types of wetlands. Number two, it has to have what we call hydric soils. So it has to have the right kind of soil or dirt at the base. That's what is needed to keep the water there for a certain amount of time. And the third component, which is what you might be able to see behind me a bit, are hydric plants. Hydric plants are super important because they serve as the base for that healthy food web that might help determine if we have a healthy wetland or not. So let's start there. When we look at our plants in our wetland system, we get many different kinds, and some of you might be familiar with some of them. So you think about duckweed, which is a little green polka dot plant that floats on the surface. Water lilies. You might even see cattails. You might see some of the water-loving trees close to the edges, like willow or cottonwood. Those are all factors that show us that a healthy wetland is there if you find those things thriving. Now, what you then have is the next level, which would be the consumers, things that are going to live within that wetland, maybe a lot of the animals. So some animals that might consume or eat the plants would be like beaver or muskrat, or even some fish like to eat little plant life, or even some turtles too. But you have those as a part of that healthy wetland system. Then you have other levels of consumers that live in a wetland. For example, you might get like bass. You might get a snapping turtle or a water snake. Those are all things that can help show us if this waterway is clean or healthy. Now, many of those things that we can't see because they like to hide from us. A lot of those top level consumers like snapping turtles, like snakes, like some of those bigger fish species, even some of the mammals that live here like mink or river otter. We generally don't see them because they like to hide. So what we do is we look at the smaller things. They're about this big, and they're what we call macroinvertebrates. They can tell us a lot about the water quality of a wetland just by seeing if they're living there or not. Now we're going to go through this together, but first we need to collect some. So what you need is a net. You need some kind of a collection device. It could be a dishpan or a bucket. And then you just need some resources. And I'm going to show you a couple of the resources that I use to help me. And then we'll do a little collecting and see what we found and see what they can tell us about the water quality in our system. So here are a few of the resources I use. You can get some of these at the library, and actually there are some online versions as well to help you identify what you found. This one's called Freshwater Invertebrates. Very good book. It has a lot of the species we have around here, and it gives you a lot more in-depth information. Now, one of my favorites, which is actually a pretty simple one, is this one called The Pond Life, and it is a golden guide book. You can get it for like $7 on Amazon if you want, but it has most everything that we find. It doesn't have all of the different species, but it does have a lot of variety, and it includes mammals, birds, other wetland species, and plants that we might find at a wetland. Another one that's a really good example is this National Audubon Society Nature Guide for Wetlands. It has a lot of great information in there as well. Now, the one that we use most often is this one. This is actually a chart from Hoosier River Watch program, which you can find information about that at HoosierRiverWatch.com online. But this is a chart that shows us the different tolerance levels. The tolerance level for, let's say, group 1, this group up here, this is very intolerant to pollution, which means that if we find them, it means that there is very little pollution in the waterway. They cannot survive if there's pollutants like oils or greases, or even things you can't see or smell, things like high nitrate levels or high phosphate levels, things like that have many different sources. But those in group 1 are very intolerant. If we find them in a wetland, it's a very good sign that there's plenty of oxygen and good variety. Now, and that's what we're looking for, is variety. So let's move to group 2. Group 2 are moderately intolerant to pollutants. And so if you find them, that means there is an indication that there could be some pollutants, but there doesn't have to be. These are ones that they don't need quite as much oxygen, and so they can survive in a little bit more intolerable conditions. Group 3 are called fairly tolerant to pollution. These are found in many different kinds of waterways. They're pretty common in many of the waterways, whether they're good, clean water or good water quality streams or wetlands, down to group number 4, which are very tolerant of pollution. The reason why many of these in this group are very tolerant is because they actually don't breathe oxygen from the water like a fish or like some of our aquatic insects do. They actually come to the surface. So it doesn't really matter how much oxygen is in it. Just as long as they can find food and stay protected, they can live in pretty much any conditions. So what we ideally are looking for is macroinvertebrates from each of the 4 groups. The more biodiverse, the better. That shows us that we have good water quality, and this ecosystem can support a wide range of macroinvertebrates. See what else we've got. Okay, do you see this one right here? It looks like it has 3 little tails. Oh, it just moved a little bit. That one is actually a nymph. It's called a Mayfly Nymph. We have a lot of different species of mayflies that live here in our wetlands. The cool thing about mayflies is that they don't go through complete metamorphosis. They go through what's called incomplete. So therefore, their eggs are laid in the water. Then they go into a nymph stage. That nymph stage then will grow. As it grows, it molts or sheds its exoskeleton, growing a little bit bigger each time until it gets to the adult stage where it will crawl out of the water. It will then spread out its wings, dry them out, and then it takes to the air. Now, mayflies are an interesting one because they tend to hatch out all in big groups, and so we see these big hatching events in May often, or sometimes in June, and they cover surfaces. I've seen big clouds of them flying at gas station lights. They're just thousands of them, thousands. But the interesting thing about mayflies is most species, when they become an adult, they have one sole purpose, and that is to find a mate so that they can lay eggs. They don't even eat as adults. Pretty amazing. Now, here's another one I'm going to show you. This little guy that's crawling over here along the edge. That one kind of looks like a roly-poly, doesn't it? But this is actually called an aquatic sowbug. Very common in our wetlands here. It is an isopod that lives underneath the water for its entire life cycle. Ooh, this is kind of fun. We've got a snail here. Do you see it moving across the bottom? Its little antennae are out. You can see its foot. Ooh, it's even blowing little bubbles. I don't know if you can see that either. But we have lots of varieties of snails. This happens to be a left-handed snail. And left-handed snails are ones that come up to the surface to get air or oxygen. They do not breathe through gill structures underneath the water, but they're very, very common all throughout our wetlands ecosystem. This is another snail. However, this is a little different than the last one. This one is a gilled snail. It's called a right-handed snail, and if you can see, the foot opening is on the right-hand side of the snail. If you do the pointed end away from you, it's getting ready to move around here in my spoon. But they actually breathe through gill structures underneath the water just like a fish would. And so we do find these a lot in our wetland ecosystems as well. Let's see. Oh, over here in the corner. Do you see what looks like that long wiggly worm? There's 2 of them. This is called a leech. Many of you are familiar or have heard stories about leeches before, and they do drink blood. Many species do. Some of them also drink juices from plants. But a leech is an important part of our wetland ecosystem, important part of the food web, just as many of these other macroinvertebrates are. A leech can swim very, very well, and when found on a human, it usually means that you've been in the water with them for a while and they're just really hungry for a meal. Maybe they're not finding many other things to feed off of, like fish or frogs or turtles. Ooh, there it's swimming across. Those are so fun. Now this one that's way down at the bottom, can you see the little insect that's coming out the end? This is an example of an insect that also, or that is, it's called a Caddisfly Nymph, or Caddisfly Larva. What that means is it's the young insect before it turns into an adult, and it actually makes a case. It carries it around with it and protects it underneath the water. Pretty cool. Some of them will even use little stones or rocks, glue them together, and that keeps them safe. Now here's another one. Let's see, where's that? Oh, this little fast guy right here. He's swimming around. That one is called a scud, or a side swimmer. A scud is a crustacean, so they're related to shrimp or crayfish, and they live in our wetlands. They're very, very common and can be found by the hundreds, sometimes hundreds in each scoop that you do with your net. But they're called side swimmers because of how they swim around. Now this one's in too little of water, but they swim on their sides and kind of go in circles. But they're very, very common, pretty much all year long. All right, let's see, do we find anything else that we should look at? Oh, there's a little damselfly somewhere. Where did that one go? Let's see if I can't find it here. Oh, I see it. It's right over here. See this little guy right there? Has kind of wider tails, little kind of wide head. There it goes, swimming across. That is called a damselfly nymph. Now the damselfly nymph, the eggs are laid in the water, out hatches this little nymph. They grow and grow and grow. As they grow, they'll eventually turn into an adult with wings, and they'll spread their wings out, dry them in the sun, and then you see them often in wooded wetland areas close to the water. As an adult, they look a lot like a small dragonfly, but a small dragonfly, when they're at rest, hold their wings out rigid to the side. A damselfly, when they're at rest, like on a plant stem, they actually can fold their wings to touch each other behind their backs. One of the big physical differences between them that you can really, really tell when you see them. So I would say this trip to the wetland was a success. Now let's see if we can't learn a little bit about what we found, now that we know what a few of the things are. For our sampling today, we did find a few things from, I think, almost from each of the tolerance level, the groupings. So in group number 1, we did find some mayfly larvae and a caddisfly. Those for sure we had. We did find sowbugs, scuds. We found a damselfly nymph from group number 2. We for sure found leeches in group number 3. And group number 4, we did have a few left-handed snails. Again, none of them are bad, but together they make a very biodiverse ecosystem. So if we found something from each level, what does that tell us about this waterway? Is it a healthy waterway or is it unhealthy? You tell me.